All right, so this is Math 2, Unit 8, Worksheet 5. This was, again, last week's assignment. I just did not finish answering questions from it, so I'm going to do that now. So, 19. What can you say about the sum, that means to add, any two rational numbers? If you're adding two rational numbers together, like 5 and 3, 1/2 and 1/3, is there any way to end up with a radical in your final answer? No, so it will always be rational. Okay, next one. What can you say about the sum of a rational and irrational? Now, if only one of them's irrational and the other one's not, there's no way for the irrational piece to cancel out. So the sum will always be what? So the sum will always be rational. I'm going to put quotes there. The sum will always be, irrational. So you need to understand that. If you're adding a rational and an irrational number together, if one of them has a radical and the other one does not, there's no way for the radicals to undo each other. It's going to stay irrational. Everybody understand that? Okay, again, you need to get it for that last piece. 21. What can you say about the product of any two rational numbers? If you're multiplying two numbers, 2 and 3, 1/2 and 1/3, if you're multiplying two rational numbers, is there any way to make a radical in it? No. So it will the product will always be what? Rational. The product will always be rational. If you're dealing with two rational numbers, it doesn't matter whether you add or multiply or subtract and divide, it's always going to be rational. All right, so now we go back to dealing with one of each. The product of a rational and an irrational. So if one of them has a radical and the other one does not, and you're multiplying them together, is the radical going to undo? No, the radical's not going to undo itself if there's only one irrational number. So the product will always be irrational. Does that make sense? Okay, so two rationals, rational. One of each, irrational. And it does not matter whether you're adding or multiplying. If you have one of each, it will always be irrational. All right, last piece here. Can the sum of two irrational, now they're both irrational, I do not have one of each. Can the sum of two irrational numbers be rational? Yes or no? Yes. Who can give an example? Yes.
7 parentheses x equals 7, like -7 parentheses x.
Okay.
Am I getting that right?
We don't want an x in there or an equal sign. So it's going to look something like this. Parentheses plus parentheses. What would have to go in there so that when you add them,
it's hot.
Is it too hot?
It's warm.
Okay. Anyone? No one has an answer? Yes.
7 plus 9 5.
Okay.
Oh, yeah, plus
And then what goes over here?
2.
2
2
minus?
9.
Beautiful. All right. Now, because it's addition, the parentheses drop, and you're left with 7 plus 9 root 5 plus 2 minus 9 root 5. And what's 7 plus 2? What is it? And what happens with the 9 root 5 and the negative 9 root 5? What happens? Do they cancel each other out? So did you end up with a rational number? So the only way to add to get a rational number is they're either both rational or they're both what? Irrational. They're both rational to get a rational answer, 5 plus 5, or they're both irrational like this one here, so that the radicals undo each other. Does that make sense? Okay. Can the product, that's when you're multiplying, two irrational numbers be rational? So can you multiply two radicals and get a rational answer? Yes or no?
No. Yes.
No?
No, yes.
Yes?
I don't know.
Not sure?
Yep.
The answer is yes. Who can give me an example? And we did talk about this in notes, guys, as well as it was in your homework. Who can give an example? No one can? Okay, let's take a look at the front piece here. Can we all take a look at number 16? Can you guys tell me, are you giving me an
That's
answer?
what I was gonna say.
Okay, go ahead and give it to me. What do you have?
That's what I was gonna use, one of those.
Okay, so would this one work?
Yes.
What's 7 times 2?
14.
And what's root 5 times root 5 because it is a pair? So you have 14 times 5, which is what? And that is rational. Did we start off with two irrationals?
Yes.
And did our product end up being rational? Same thing with number 13. What's 4 times 2?
8.
8. What's root 12 times root 3? And they're not the same, so they don't undo each other. Root 36, but is that a perfect squared? And 6 times 8 is? 48. So these are two examples of multiplying two irrational numbers, and the product is rational. So who can now give me an example? Square root of 7 times the square root of 7, because it comes out as a pair to just be 7, which is rational. All right. What is the only way to add or multiply to get a rational number? I'm going to repeat the question. What is the only way to add or multiply to get a rational answer? The two of them have to be the same. They're both rational or they're both irrational. If you have one of each, is it still going to work? Like here, if you have one of each, is it still going to work? Is it still going to be rational? No. So I'm going to repeat it. The only way to get a rational answer when adding or multiplying is your original two numbers either are both rational or both irrational. All right. Are we good? All right. This is where kids struggle right here on the test, so everybody's listening. I'm looking for, using this set of numbers, choose two numbers that when you multiply, it's rational, and when you add, it is irrational. Okay, what is the only way to multiply to get a rational numbers? The two numbers have to be both rational or both irrational. Well, if I needed to add up to be an irrational, would it make sense to use numbers like 5 and 6? Would that make sense? That would not make sense. Why not? What is 5 times 6?
30.
And is that rational?
Nah.
That's good. But what's 5 plus 6? Which is still rational, and I want it, it's rational, and I want it to be what? Irrational. So, the two numbers you're putting together then would both have to be irrational. How do we know we need two irrational numbers? Because when I multiply, I want them to undo each other. And when I add, I want the radicals to stay. I could tell some of you guys are not paying attention. And this is on the test that you're taking tomorrow. So you want to make sure that you understand. Okay, I'm going to repeat that. I want two irrational numbers so that when I multiply them, the radicals undo each other and I get a rational number. But when I add them, the radicals stay in. Can anybody give me two numbers here that when I multiply, the radicals undo each other? Yes?
2 root 6 and 2 negative root 6.
Okay, 2 root 6 and 2 negative root 6 is one whole number. So when I multiply, I would have to distribute. And unfortunately, when I distribute, this piece would undo, but this piece here would still have the radical. So you're close. It is something with the root 6 or the 2 root 6. All right, so another one, take a shot. Yes.
2 root 6 and root 6.
2 root 6 times root 6. And over here, we're going to try 2 root 6 plus root 6. Let's check if that works. What's 2 times 1? And what's root 6 times root 6?
6.
So 2 times 6 is, and is that rational the way we want it to be?
Yes.
Yes. All right, what's 2 root 6 plus 1 root 6? And is that irrational?
Yep.
So did it work? Yes, so that was 2, what was it? 2 root 6 comma root 6. Again, we were looking for 2 irrational numbers so that when you multiply them, the radicals undo each other, which they did, and when you add them, the radicals stay, which it did. You need to understand that. All right. Now we're going to look for 2 other numbers that when you multiply them, they're irrational, and when you add them, they're irrational. That's a little easier. As long as at least one of your numbers is irrational and nothing cancels each other out, you're good. So, anyone want to take a guess? Since they're irrational, I would pick 2 numbers that don't even match, like
5,
these
6.
2 or the 5 and a radical, any combination. 5 and 6? The only thing with this is they're too rational. Whether I add or multiply, is it ever going to come out to be irrational? 5 and root 6. Okay, let's see. 5 times root 6 is what?
5.
Root 6? And is that irrational? Check. All right. How about 5 plus root 6? Are those like terms? Is 5 plus root 6 like terms? No. So when I add them, what do I end up with? 5 plus root 6. There's nothing I can do. Is that also irrational? Check. So those numbers are good. 5 comma root 6. So here you're looking for 2 irrationals that undo each other when you multiply but not when you add. And here you're looking for any combination of 2 numbers that stay rational all the way through. So it's a good thing to pick an irrational or rational. That will always work. All right, questions on that one there? All right,
Is that going to be on the test?
it is. That's why I have a star by it, because it's one that kids often miss on the test. All right, 26, 27, 28, 29 are other ones that kids often miss on the test. Are you ready? Do we want to see that one? Yes? All right, so here is what I'm trying to get. 8x to the 5/4, do we all agree? And they're asking us to determine whether each expression is equivalent to this, yes or no. All right, here's the first thing I check. What looks most alike? Do you agree x to the 5/4 and x to the 5/4 is exactly the same? Okay, what's not the same? This has a coefficient of 8 and this has a coefficient of 6, not just 16, but 16 to the 3/4. Do you guys agree? So here's the question. What does 16 to the 3/4 simplify or evaluate to? How do I evaluate this? We've done a few of these guys. Change it to which form?
Oh,
radical.
4.
root 16 to the 3rd.
Good job. So we do the 4th root of 16 first. Do you guys agree?
What is that
Fourth-
form called?
What is radical form? Because it's the radical symbols there. Okay, break down your 16. 4 and 4, 2 and 2. How many 2's do I have?
4.
1, 2, 3, 4. Raised to what power? 3rd. And do I have enough for one whole chunk to come out? What does it come out as?
2.
So I'm left with 2 or 2 to the 3rd?
2 to the 3rd.
2 times 2 is 4, and what's 4 times 2?
8.
So did 16 to the 3/4 simplify to 8?
Yeah.
So we're left then with 8x to the 5/4. Is that the same or not the same?
Same.
Same. All right. Next one. This one's a little easier because do you agree that x to the 5/4 matches?
Yeah.
Does 16 have a power?
Uh,
Of 1. Is 16 to the 1 power ever going to equal 8? No. So there's not really any work to do there other than to notice 16 by itself is never going to equal 8. Why did this one work if they both have a 16?
The 16 did not have it.
This one did not have an exponent, but this one did. And it's not just any random exponent. The 3/4 is what it was needed to get the 8. If it was 3/5, it wouldn't work. All right. So next one. This is another easy one. It's kind of squished together, but this is what it is. Okay? This is that 8 has a power of 1. That 4 is the index, x to the 5th. So what does that become? 8x to the what? 4/5 or 5/4? Same or not the same? Same? This next one is tricky and it gets kids every year. Can I have everyone listening?
Yes.
Okay, this one came up on the quiz. Came up on the quiz. Not in this form, but it said right here, it had this, and it said rewrite in exponential form. Rewrite in exponential form. And I'm going to show you what it looked like on the quiz really quick. I believe it was the cube root of xy to the 6th power.
Yeah.
And I had a lot of kids say, oh, it's xy to the 6 over 3. Is the 6 over 3 correct?
Yeah.
But why is this wrong?
Because it's asking for the cube.
For the X.
The x has a power as well. What's the power here?
1.
So the cube root of xy to the 6 really equals x to what power? 1/3. And y to what power? Which is x to the 1/3 and y squared, which is not the same as xy squared. Do you see that? All right. So don't forget that 6 is only on the y, not on the x. Do you see that? So the x has its own power of 1/3. So with that being said, what's the power on the 8? Can you guys please stop? 1.
Me.
So what does this become? 8 to the what power? 1/4. And x to what power? 5/4. Does the x to the 5/4 part match? Is 8 to the 1/4 ever going to equal 8 to the first power? No. All right, questions?
So tired.
It's not going to work that way all the time. All right, so remember 25, 26, 27, 28, 29 is where kids struggle on the test. Make sure you review those. And I'm going to now have you flip over to the practice test. I am going to give you even answers and then answer questions. I am going to give you even answers and then answer questions.